let's talk about beautiful Garland from Cold Chef. So, in this problem, we have a Garland, a cyclic rope that is described by string S, and because it's cyclic, it means that the last letter is connected to the front letter. So let's say in this example is RG. What it really is RGR, because the G is connected to the first letter, which is still going to be R. Sorry it's a little confusing for now, but it's going to be important later on. It's like, so because remember, this Garland is going to be in a circle, so if we have let's just create like a brief circle right here, and this is less than a circle, but more of something else. This is actually, it's less than this is not a circle, that's a square, but this is going to be connected to, R is going to be connected to G, and then we have, okay, where's the, do we have anything to, I swear, was there, okay, that's gonna be annoying. Let's just say we got that connected to that, and we have this connected to that, and this R is gonna be connected right here. As you see, all these are going to be connected in a cyclic loop. So in the string RG GR, this R is going to be connected. These two are connected. These middle two are connected. These two are connected, and the first and last letters are connected. And if we want to represent that, all we need to do is just take this first letter and just bring it to the front, and we can just loop through this. I'll show you when we talk about the implementation. But a Garland is beautiful if there's no pair of adjacent flowers that are identical colors, meaning they have to alternate. Okay, what this tells us is, first of all, the last two letters cannot be the same when we end this. Next of all, whenever we're able to flip any two. However, we come into an issue. This does not always work, and let's explore when it doesn't work. So let's give a case that looks like this. Okay, we see that R and G and R, these two should not be together, but so we can switch them, and as you see, we have it works. So this would be a yes. So this would be yes. But what if we try one that looks like this? Well, first of all, we know it doesn't work, because in order for this to be beautiful, the number R equals G. The number of R's has to equal G, because if you think about it, in order for this to alternate RG, because it has a GR, 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 or RG, 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 with the last one being different from this, we see that we can group them into twos, and that in any group of two, there can only be a GR, and it has to be GR, or RG. And so there has to be the same number of occurrences for both R's and G's. Now, let's focus on what else we can use just to our advantage. Okay, so if we ever see them occurring twice in a row, or like if they occur like this, in order for this to work, you would have to split the R's. So right here, where there's an in between, you would swap it. But then you run into this issue. You can swap these. Wait, hold up. Wait, sorry. You can keep swapping them, because you can split into two, right? And we come into this issue right here, and it's that. Okay, sorry. Wait, let me just review this, because I recall we can reverse one of these two parts, make a cut, make two cuts, splitting. That doesn't necessarily make sense. Maybe it's just around like one cut. So okay, let's think about it again. Okay, we have RRG, RRR, GGG. We can cut it into two parts like this. Okay, and it can be GRRR. Cut it into another two parts here just to try to fix it. But then you see that any given time you try to swap GRGRR, you see that if the R's appear, we're looking for any occurrences of RR or GG. Any single time you see them appear twice in a row, you realize that it could only happen once. Because if they happen more than one time, it can be shown that it's impossible for you to make a beautiful Garland when they appear, where RR or GG appears more than once. And even then, like, both have to be the same number of occurrences. We already guaranteed, because think about this. If RR equals 1 and GG equals 0, R does not equal G. Because that means every other occurrence is of some form of RG or GR, where the two next to each other aren't the same. So let's implement this. So scanner, we set up our test cases. Or string, we can use next because there's no spaces in between any. Well, every line does not have a space, so we can just use next and it wouldn't mess up our test case. Then we have RRGG and RNG. RR indicates the number of times we see two R's next to each other, and GG indicates every time we see two G's next to each other. But before that, we had to add the last letter, like I said before. So you have RRGG. We want to add the last letter. That way we can check this one's whether this one is the same as this one or they're not the same. Then we're gonna loop through it, and we check if both of them are the same. If they all want to increment RR by 1 or GG by 1, depending on which of the two are like the same. So like if both are R's, we increase RR. If both are G's, we increase GG. Then we look through it again. Well, you don't have to do this. You can just do RR equals GG, but I'm making this a little easier to understand. Both of them have to be the same. So, and we're checking how many times R appears and how many times G appears. We use -1 here because we don't want to check the last value that we created, because this is technically not part of the original. We just put there just so we can check connectivity. So it's just like an extra that we don't count. And we see if RR is less than equal to 1, GG is less than equal to 1, and R equals GG. If it does, we print yes. Otherwise, if it fails these conditions, we're going to print no. And submit. Well, submissions. We see this was the same one. And so it was accepted. And proof of case. And you look at submissions. Passed. Now, of course, this is a greedy problem, so there's not like a defined algorithm that you have to make. It's more how you think. So keep that in mind when doing these types of problems.